Welcome everyone! My name is Will the Chill. Greetings! Some of you may know me by my legal name, Will Braswell, and sorry we had a technical problem with our little device, but now it's fixed and working and we can actually move on. So, today we will be looking at the PerlGPT Meta CPAN Curator. This is a new AI project that is currently underway. I'm developing it in collaboration with the AI Perl Committee, and this is a work in progress. So we're going to go over a lot of different aspects of the project. So and hopefully we'll actually be able to get to look at some of the code here and so forth here in a minute. All right. So what is PerlGPT? First of all, PerlGPT is our new LLM that we're designing specifically for Perl. So it's a large language model project that will be built specifically and only to specialize in Perl. So there's all kinds of different models already for other languages. But none of them are specializing in Perl. So that's our entire point to this project. But it's not just about PerlGPT, it's about this thing called the Meta CPAN Curator. This is what we're using to build our training data set. The training data set is all of the best Perl code in the world. But who's to say what's the best? Well, again, my name is Will Braswell, Will the Chill. Some of you may know me. I wrote the Perl compiler, the Perl community roadmap, founder of the Perl committees, and so on and so forth, Perl town hall and everything else. So I am doing my best to programmatically determine and define what is the best Perl code in the world. So that when we feed this all to our new Genius AI system, we will only be giving it good code to learn from. So that's important. Garbage in, garbage out. We'll come back to that in a minute. All right. There are, like I said, other models. You've probably heard of Llama. That's kind of the big important one. We'll be basing our system off of Llama because it's already a very good system. But we're going to do a lot of fine-tuning, like I said, with all of this amazing good Perl code that we've got. So that's basically our main sort of a goal is to, Llama is the basic foundational model. Then Llama is the foundational coding model for source code programming. Then Llama Python is the specialized model, super specialized model for that evil, wicked snake language from the devil from heck that we got to get rid of. So they've got Llama Python. And by golly, it's a good language for that dang. It's a good model for that dang snake language. So we've got to create Llama Perl, which is essentially the Perl-Llama is another internal code name for PerlGPT. That's what this project is. So you can, I don't want to bag too much on Llama, but I do need to bag on them a little bit. They're very smart people. These are the smartest people of Meta, Facebook, right? And they came up, this is the idea that they came up with of how to train their model. It's very interesting and wacky. So they take some other existing model, like they have their own internal models, but let's just say for the sake of argument that they took ChatGPT, which is another company's model, right? OpenAI owns that one. Let's just say they took ChatGPT, or anybody. Let's just say you guys decided to take ChatGPT. You ask ChatGPT to generate 1,000 interview-style questions, which we all hate. And I was just chatting with the chairman of the AI Perl committee just a few minutes before we started here, and he was telling me how he hates one of the companies here that's currently hiring because all they do is interview style questions that don't actually measure your abilities. And I should know because he's the maintainer of Catalyst. So, I mean, you don't get any higher ability in web applications in Perl for like the whole world, right? So anyway, nevertheless, they decided to go with this route. So they have let's just say they take ChatGPT and say, give me 1,000 interview style questions for a computer programmer. In this case, it's Python, right? Because they were doing Python. Llama Python. Then they had a different language model, or maybe it's let's just say ChatGPT's specialized coding system to write 10 possible solutions to each of those 1,000 questions. So now you have 10,000. And really, if the numbers are, I think, higher than that, okay? But I'm just using round numbers. Then you use a third different this is all based on these friggin' models. It's basically the blind leading the blind. I'm just going to cut to the chase. They've got a model leading a model leading a model leading a model. Well, where the frick does this thing come back to again? It's like a monkey chasing its tail or something. Literally, that's what it is. And so they end up eventually having another model choose which of these 10 answers they like best for each of the 1,000 questions. And then they munge that thing some more eventually, and then they come up with some training data set based off of that. That is how they generated the training data set for the #1 coding system in the whole world right now, Llama Python. It's fake all the way down. So we reject this methodology as being inappropriate for many reasons. Number one, and first and foremost among these reasons, is the intention. Where is the intention of the programmer? Where is the intention of a human being in this process? Okay, and the answer is it's almost completely absent. Because all they really did in the beginning was say, write me 1,000 interview style questions, and that was it. From there on, they had no more intentional input there. So the only intention that these humans had was to not do any work themselves, which is perhaps sarcastically speaking, laziness, impatience, and hubris are supposed to be the 3 virtues of a programmer. But really, if you read what Larry said about that, St. Larry Wall, as some may call him, then it's basically you're supposed to be lazy by reusing well-written code that you or someone else already wrote and not rewriting the same code over. That's what he meant when he said lazy. You got to go read what he originally wrote about that. These were all sarcastic comments. He didn't actually mean for anyone to be lazy, impatient, or proud. Okay? So, these guys at Meta came up with this amazing way to be ultimately lazy with no human intention involved in any way. So, my contention is that the human intention is the mother of, everyone, invention. Okay? Why? Because that's what makes everything in the world go round. Human intention. That's it. I mean, sure, Mother Nature and animalistic processes, but I mean everything in the civilized world where we live and talk and breathe here. Certainly everything in computers should be based off of some human intention. A lot of things may not be, but even things like viruses, those are based off of bad human intentions, right? The intention is to mess up somebody else's system. So when you get to something as complex and I should say ultimately complex as source code, because there is nothing sort of understandably more complex than there is something more complex than source code, which is neural networks, of which LLMs are a subset, but it's not understandable. It's essentially the same thing as the mishmash of neurons in a human brain that maybe someday with some super advanced magical technology we may be able to understand it, but not right now. Source code is definitely the most advanced understandable information that we have available, okay? So when it comes to this most advanced type of information, which is source code, you have to have the human intention. That's the most critical thing. And the only way to really get that is with the documentation, because that's where the human programmers write down their intentions. That could be in the comments, or it could be in the pod, or it could be in a README file or some other place, or like all of the above, usually for well-written Perl distributions. But if you go to MetaCPAN and look up somebody's code on there, they will tell you what their code is meant to do, right? And what we're doing is trying to get at that information and then tie that to the source code that is implementing those intentions, and only the good source code, and that is what we should be using as the training data set. Because now I can tell my future LLM, PerlGPT, what my intentions are for my new project, and it will actually be operating on the level of intentionality into source code, rather than this sort of fake interview question into source code process. They're very different theoretical approaches and practical approaches to describing and generating a AI training data set. So I said I wasn't going to bag on them much, but I guess I was lying. Sorry guys, but whew, they got away with it in the sense that they were able to create Llama Python, but this is a first generation coding system. So of course they got away with whatever it was, because whatever they did was what they got away with. No one knows any better. There is no other benchmark or baseline to even measure it from, because it's the first one. So we were able to measure a few others against them, and Llama is the best so far. So anyway, let's move on, because I'm going to go way over time and so forth. You're going to have to scroll through all this stuff. I will say that we had a few requirements I'm going to go through, and a few design issues we're going to go through, and they are important, so I won't skip over them, okay? But at the same time, I can't go deep diving in all this because this is a 34-page academic paper. You want to get this paper? Buy the book. It's in the back of the room. The Science Perl Journal, Volume 1, Issue 1, available now for sale for the first time ever. This is the first announcement of this sale. So get it before you leave. We got to be able to do all the basic stuff that I just described, using the CPAN, source code as our input, only choosing the best code, generating the high quality data set, and then just other stuff like it has to run on a computer system that's not like an expensive server or something, but like a normal laptop system. And I tend to use older systems, so I don't want it to have insane requirements. The architecture, it's the same basic architecture. This is mostly for people that aren't familiar with Perl distribution architectures, but if you don't already know what like the lib, bin, and t directories are, then please, learn about how to build a Perl distribution. So I'm not going to go into any of that. The design, this is more important. So we got to have a lot of comments, like 1-to-2 ratio comments to code. So like 1 line of comments for every 2 lines of code. Why? I just said it a minute ago. What is the number 1 most important thing? Somebody. Starts with an I, rhymes with invention. Intention. And where is that intention codified. In the documentation, and one of the most important parts and the most technical part of the documentation starts with a C and ends with an comments. Okay? The code comments are where the nitty-gritty of the technical intention of the programmer is codified. And if it's not, you're doing it wrong. If you're not writing this many comments, I hate to tell you, but I'm passing the judgment from on high that you're not doing it right, because you're not adequately capturing your own intentions. User-defined names, this is just basically saying that we need to use a descriptive variable and subroutine names, so we don't name things foo and bar and XYZ, but they all have to have a nice long descriptive English name. Why? Again, the same exact reason I just told you, and I'm going to keep saying this. What's the number one most important thing? Intentions. Because if you do not have a descriptive name for all your user-defined elements, subroutines, variables, whatever, then you, again, exact same thing I just said. You have not adequately captured your own intentions. And you're hiding your intentions from the rest of the world and from the AI, and we're going to take your code and very politely and tenderly put it right in the trash can, because it's no good. I'm describing the designs principles that we used for both our own implementation and as the quality metrics to determine the intention and usability of other people's code. It's one and the same. That's a critical, important point to understand. Now, we write object-oriented code. There's a ton of non-object-oriented code on CPAN, and that's fine. We're not filtering out your code if it's not object-oriented. However, there are many ways to write badly object-oriented code that will send off flags, and when that happens, you may end up getting your code filtered because you wrote some crazy object code that doesn't work right somehow, okay? Strongly typed, yes. If you do not know how to use the Perl data type system, I can help you learn. But basically, you need to declare the data type of your variables and subroutines. People in Perl think you don't need that. Again, I'm here to, as politely as possible, tell you that you're woefully and wildly mistaken. You need to have data types for all your variables and all your subroutine, all your user-defined constructs. Because, and I'm going to, God dang it, keep saying it. What's the number one? Everybody's got to say it together. Then I'll have to stop saying this, okay? We're all going to say it together. The number one most important thing is intention, okay? Because if you do not tell us what the type of data is that you're using, you are, again, to quote myself again, you are not adequately capturing your own intentions. You're hiding your data usage from the world. And you should be punished and your code will be discarded. Well, that's not true. We're not filtering people based off of a lack of data types, but we are giving people additional consideration when they do provide that information, just like any additional annotation of your intention should garner. Okay? The more you give us your intention, the higher your score is on the quality metric. Low magic. Don't do stuff that's hard to understand. Don't use secret operators. Don't use purposefully obfuscated code. If you're doing that, then you're either just silly, crazy, or you're purposefully trying to mess things up for other people. And really what it comes down to is, it was this, and I won't wax too much about it, I'll try and do it in just like 2 or 3 sentences. But it used to be cool that Perl could do all this magic stuff until people realized it just made a bunch of line noise or write-only language. Okay, it got us a super bad reputation. And then it became a way for the elite few to have job security, which I think they're still enjoying now to the detriment of the reputation of our language, not to mention all the problems caused by the absolute, utter, and catastrophic failure of Perl 6, which is really the main problem. But this is a secondary problem that those people remaining with real Perl, the old guard had this mistaken idea, and it wasn't really an idea, but it's more of a modus operandi, that if your code works really well but no one else can understand it, then they can never fire you. And then when you die, your code dies with you, and they're going to delete all of the Perl code base and rewrite it in something else, or go out of business trying, which is usually what happens. So you're actually essentially dooming your project and your company by doing that. But that's what people do. And last but not least, we did parallelize the code because it's very computationally intensive to do all of this stuff that I just described. Whew. So all of those things apply to all the filters that we have to apply to other people and to our own code. I'm going to skip past a ton of stuff that pertains to all that stuff I just said. If you want to know what the real data types are, look at table number 1. If you didn't know, again, that Perl has data types, I'm here to tell you that it does, and you need to be using them. But this is all the stuff that I just went into. Okay, the implementation. There are several phases in the implementation. Whew. And again, there's so much into each one of these. They have a whole section here in the paper that I can't get into. But I'll try and just talk about it for a minute. So, in phase 0, we're downloading the stuff from CPAN, making sure that all the files are there and they're not broken and that there's nothing missing, and that it has all the metadata. Because what do you think is in that metadata? At least a little bit of the programmer's what? Intention. Okay, because it has stuff like their repo and their name and the date and the copyright and the owner, and there's stuff in there. There's important intentional stuff in there. And in fact, if you don't have some of that metadata, you will immediately die and get filtered out. Because you have to have that for people to be able to actually use your software correctly. Not all of it, but some of it is critical. Some of that metadata is critical. Phase 2. Quality with a K and a W, CPANs, or C shorts perhaps, short pants. So this is a way to determine if there are parts of the distribution as a whole that are considered to be low quality. Now, this does include things like missing pod files. We already talked about that. Your intentions are in your documentation. And this lets us very quickly filter off those. And many other things. If you don't have a README, if you're not using strict warnings, it can do a lot of very useful checks very easily and relatively quickly. And so we make very good use of quality. And a lot of people hate on quality. And I'll tell you why. Because their code is low quality. And of course you're going to hate on a system that clearly points out your own faults for everyone to see. And when this first came out, it was like, we're going to run this on everybody's code on CPAN and make it a big stamp right on the front of their thing or whatever. And I'm sure it bent everyone out of shape because they didn't want to make their code be high quality. And so now it's like a background thing that I think you can find it somewhere. You have to go to a different server and you have to, it's no longer a big, major, important thing that people care about and utilize. But it's still there, and it is very important for what we're doing. Phase 2, Perl Tidy. Raise your hand if you've ever used Perl Tidy. Okay, you should. It's very good and useful. It's very nice. This one is not so much a strict requirement. We're not filtering people based on untidy code, but we are filtering out untidy code by tidying it. And actually, I should say, there are a few distributions that are not able to be tidied for highly technical and weird reasons that I can't get into it, but talk to me later and I can show you some bugs. I have found bugs on all of these phases. Not bugs with my software. Not bugs with the software that we're analyzing. Bugs with the software that we're using for analysis. Okay? Bugs in Perl tidy, bugs in quality, and so forth, because we're applying this to thousands of distributions. So we're going to find those edge cases. So we're only filtering out a very tiny percentage that can't be tidied. The 99-point-something% are fine and they're able to be tidied. And we're using that so that the code we're passing to our AI is going to be uniformly formatted. And when it writes us code, it's going to write it in this uniformly formatted manner. Okay, phase 3, Perl Critic. Raise your hand if you've ever used Perl Critic. Perl Critic is great. It's also hated by many people for the exact same reason as quality. Basically, quality is for your distribution and critic is for your individual files. And they operate very differently and they're testing for different things. They do test for some of the same things, like use strict and warnings is actually detected by both quality and critic. So there's a few little bits that overlap there. But by and large, there's, dozens of tests in quality and hundreds of tests in critic that are 95% different, okay? Just a few overlaps. So critic is going to analyze each individual source code file in each distribution, and it's got all sorts of things that it's going to complain about. Now, we're only accepting its criticisms regarding the most critically important considerations, pun intended. Anybody catch that? Critically? Yeah. No? Yeah, no. But when they are critically important, then we accept the critique and we filter. Sorry, but actually, I'm actually currently allowing them through the filter, but I'm annotating that they have a failure of criticism. So I'm actually editing the source code directly and inserting a comment that says this in the line, the very line that failed, that says this line fails the criticism of not using strict or whatever. There's hundreds of those, but it inserts in plain English as if it were the programmer themselves criticizing their own code. My own code fails in this line in this criticism. So that, at the very least, if our AI needs to write code like that, it will know that it's writing bad code. And I'll be able to tell it not to do that if we really don't want it to write. And I'm going to have that as the default. Do not write code that would fail these criticisms by default. And if it says I'm having trouble doing that, then maybe we could reconsider. But that's important. People hate Perl Critic because they have low quality code that cannot pass the tests. And I dare say few of us could pass the test on the medium, and nobody except for me, I think, in the whole world can pass the tests on high.
And that's just because I wrote the Perl compiler to use it and to do that specifically. And even I had to create about a dozen exceptions, which you could consider to be a Perl critic policy of don't fail on these things, because, for example, you cannot say print hello world on the most severe criticism level because it wants you to check the return value of every operation. So you have to say print hello world or die. I don't know how print hello world could fail, but apparently it can. So I disabled that. That's one of the ones that shouldn't be, causing your code to fail. Phase 4, PPI. PPI is what is used by Perl-tidy and Perl-critic, but it's buried inside of their code, so we have to run it again directly ourselves. And PPI is a Perl parser. It's got some backronyms. It's basically it's using Perl to try and parse Perl. Obviously, you can't parse the parts that are dynamic runtime only behavior because only the interpreter can do that, but you can parse the static parts. So it does not parse into an abstract syntax tree like a normal language or an op tree like the Perl interpreter. It parses into a Perl document, which is essentially the closest thing you can get to parsing it into one of those other tree formats, but static. So then finally we use that parsed source code to generate our training data set. Right now I'm just using Markdown as an intermediate format because it's easily human readable, but it will eventually get put into CSV files, which are trivial. They're just like two columns or fields, like stimulus response, basically, from what I understand. We haven't gotten all the way to running the training system yet, auto train, but we're getting close. So we don't have time again to go into each one of these dang things, but holy cow, it's a ton of in-depth stuff. I will just mention a few. So here's some of the quality metrics. Okay, so it has to have a README file. It has to have tests. It can't have broken code. It has to use strict warnings. Remember, I said those are checked by both quality and critic. So those are the things that quality checks for. Perl-tidy. If you care what our Perl-tidy policy is, the configuration system we use for Perl-tidy, it's right there. It's basically the same system that I developed with Perl-tidy's usage in the Perl compiler, and I just copied it over and adapted it for here. Perl-critic, we're only taking things that are on these two level. So we're not trying to go brutal on the code because we'd be annotating 3 or 4 annotations on every line in every distribution of CPAN. This line fails the following dozen policy, criticism. We don't need that, okay? We only need to know about things that are very severe, okay? Very severe issues. So I can't remember if I put an example of one that showed a code that was critiqued, but again, I found here's some of the things that cannot be run through Perl-critic for various issues that we can't get into right now because we don't have time. Parallelization. This one is important. I wanted to mention this because memory leaks and parallelization. This was a huge bug that we found, that basically PPI, which we use directly and indirectly through critic and tidy,
PPI is very complicated, and in order to parse Perl, it has to like recursively call itself a whole bunch of times and keep doing a bunch of tricks until it can create these Perl documents, like I said. And in the process of doing that, it creates call stacks that are so complicated that the Perl garbage collector cannot free memory. In other words, massive, unstoppable, absolutely terminal memory leaks that will completely crash your system. And there's no way to stop it. You cannot debug PPI. You want to try? That's fine. Just make sure you bet me as much money as you have before you do it, because I know you'll never be able to succeed. It's like we may be able to have PerlGPT itself help us with some intractable problems like refactoring PPI or having the Perl garbage collector be able to free that memory, but right now just assume that PPI is unfixable and that anything that uses it like critic and tidy will leak if you try and run them repeatedly or run them on multiple files or whatever, like exactly the same exact thing we've got to do in this program. So I was trying to like, oh man, am I going to have to try and fix somebody else's software? I tried to get into like the C code and all, it's trying to run, you know, the profilers and the debuggers, and it was just like I was having flashbacks of the Perl compiler and all over again. And it's like that when you get to that level, you need to understand it's probably unfixable. That is a life lesson, that if you're trying to debug someone else's C or XS code and you're a Perl programmer, man, you've probably gone too far, okay? Unless you're also a C or XS programmer, right? But even then, you've probably gone too far. So I went too far. I didn't know, I had no real other recourse until someone, thank you, Zachy Mogul, said, oh yeah, PPI leaks like a sieve. And I was like, oh dang, well, why didn't someone put this in the documentation or let anyone know? It's just a hidden secret. One of the many not cool things about Perl, we have all these hidden secrets. Not all secrets are bad, but most of them are, okay? And that's a bad secret, that PPI is just unusable when you try and do this scaling. It's unscalable. So if you wrap the whole thing in a parallel process on the operating system level, it will fork the Perl interpreter. You can run PPI and everything for a whole distribution, and it's going to bloat up your whole memory until it almost crashes your system. But then when it finishes with that distribution, the operating system will end that process, and the Perl garbage collection doesn't matter anymore because the Perl interpreter fork is being shut down, and it will completely free all of that gobbled up memory. So we were able to not solve, but completely work around that problem. So, Parallel Fork Manager is your friend. Use it if you haven't already. Let's see, is there anything else that I need to get into before we get into the final thoughts here? The memory leaks came back again. Oh my gosh, you know why? Because if you try and parse Japanese characters, it will, again, it will have an even more insidious memory leak. Get this, that will not go away when the operating system kills that forked process. I don't even know how that's possible. It's somehow causing the original Perl interpreter to maintain some other Perl interpreter's memory leaks. I don't know. I don't understand it. It is beyond probably the understanding of anyone here. Not in this room. I mean in the conference. And maybe in the whole world. Okay? Because it's I mean, someone's going to have to eventually figure it out, maybe, but it won't be me, and it won't be anytime soon, because I just have skipped those for now, set them as a skip, and I'm sorry, but the Japanese zip code verifying system will not be one of the high quality code modules included in the training data set right now. Hilariously and ironically so. Also, you cannot include kanji characters in LaTeX, apparently. So I had to cut those all out as well, because it was crashing LaTeX. So yeah, kanji, hard to do, apparently, in general. I'm sure it's possible, but not easy. You want to see what the Markdown looks like? I'm scrolling past it. It's basically questions and answers. Will you please create a new Perl software file which provides some human intention? Finally, we got back to the intention. And then this thing says yes, and it writes all the code for you. Okay? This has to be done across 4 levels of granularity. You should be able to ask it to create an entire distribution, a single file, a single package, or a single subroutine. And it should know how to do all of those layers stacked together or individually. Okay? So I should be able to say, and I quote, will you please create a new Perl software distribution which provides a library capable of what? Make something up. Somebody make something up. Validating zip codes without crashing the Perl interpreter. And then it should be able to create an entire distribution. Upload ready. You can even say, and upload it to CPAN. With a full running test suite. As if you were a senior Perl developer. Or if you want it all the way down to a single subroutine, just write me one subroutine that just does this one thing, please, go. That's it. And anything in between. And that's the granularity levels that we're splitting it up between. We're out of time. The results. I don't even have time to pull up my code because I had to reboot the machine, but I will tell you, out of the latest 5,000 distributions on CPAN, which is by no means all of them, that's just as many as I've been able to run so far, about 2,700 of them pass. So just over half. And this is using, again, my best guess abilities to come up with what are reasonable settings for the filters of all of those layers I just described to you. Because I could have set any one of those phases to any different configuration and it would wildly affect what's filtered and what's accepted, either up or down. So I will try and end by saying ChatGPT and Perl-Llama are very good, but they don't do Perl for well enough for anything, production really. And the final thought that I'm going to leave you with, garbage in, garbage out, okay? So what I described as the garbage training mechanism of the fake interview questions, or alternately speaking, the code, the Perl code that Perl-Llama is trained on is a random collected assortment of GitHub repositories with no quality metrics of any kind, which I would also consider to be essentially garbage code. I'm sure there's great code mixed, but it's just mixed in with all the other garbage. So that's garbage in, garbage out. And we're trying to reverse that and make it gold in, gold out. We're only accepting the best code, and we're only allowing it to generate the best code as well. So with that, I think that's pretty much the final thoughts of what I can get to. You can read the whole paper. All the acknowledgments are there. But with that, I give you the PerlGPT Meta CPAN curator. Thank you very much. Come back next year.